think of your system like a self-driving car. It's impressive that it can move on its own, but nobody trusts it unless there are brakes, sensors, and overriding control. That's exactly what production safety is. A self-improving loop is only valuable and viable if it can operate safely under real constraint. That means containment, anomaly detection, hard stop signals, and control autonomy. This lesson is where everything becomes real. We are not just building a loop anymore. We are building something that actually you can deploy. I want you to zoom out for a second and the entire course as a one real world example. Every lesson we added had a mechanism, but none of those earlier pieces has disappeared. They're still running. Let's recap what we have built. A bounded genome, a deterministic orchestrator, a feedback signal that you can actually read, challenge pressure to avoid lazy convergences, and search and re-ranking for better candidates. Now the question is, can they survive the production? We are not adding something optional. We are wrapping up everything what we have built inside a defensible safety model. So keep the system in your head: mutation, evolution, feedback, selection. And now we add safety around every step, and that's a final layer. I think this is a layered defense system. The core, you got a sandbox in. Anomaly detection, that's around it. And then permission control. Here is a mindset shift. You assume things will go wrong. Not maybe, not rarely, always. So instead of hoping your candidate behave, you contain them. Like running untrusted code in Sandbox. Let me share a very good example that actually happened to us. We had a debugging agent, and then debugging agent has actually a root control because it needs to run LLMDB or C++ debugger. Now somehow the LLM figured it out that this control is administrative privileges. LLM was not able to find a way to run certain git command. However, it established with the root control it can, and it actually jailbreak by just identifying that one debugging agent can actually fire the root execution commands, and it attempted the git rm. However, it was very quickly spotted by us because there was also a hook which was protecting those particular command which we anticipate, and we do not want to run it. However, that has given us so much reasons to worry about it, because we knew that this command may actually cause a problem and we put in a hook, but there might be a command which we didn't know, and it could actually cause a real damage. We have seen many online examples where jailbreaking is a real case scenario. So let's always make sure Sandbox is must. It is not an optional. Some failures are fine. Repeated failures are not. You install tripwires. Some failures pattern, same failures pattern repeating. Metrics degrading consistently. Unexpected drift. When that all happen, you stop the loop. Not retry, no let it run, just stop. This is when a lot of them messed up. They jump straight to the fully autonomous, and that's the classy mistake. Instead, they should have moved the labels such as manual, assisted, supervised, autonomous. Promotion only happens when evidence proves it is safe. Let's zoom out last one time. Contain execution, monitor behavior, stop damage early, increase autonomy slowly, and that's how you make it real. And before we jump into the lab, the full implementation in the GitHub repo link is below in the description. Make sure you have it open before we going to do the walkthrough and controls together. Alright, let's close this properly. I'm sure you got the GitHub repo checked out and everything is ready. What we do: inspect the sandbox boundaries, filter the failure scenarios, and observe. 3 questions we should ask: does it get contained? Does system detect it? Does it stop or retry? What to focus on: where execution is isolated, where the state reset happened, and how the autonomy level is exposed. An important system is not pretending to be fully autonomous. It is showing you control. That's what production systems do. And a last request. If you want to keep building system like this, hit the notification bell and subscribe our channel. So we are on the hands-on lab, and best place to start is 07 production safety. You got a diagram here, and you got 3 flows which help you to understand how the code actually works. We already start safety with containment. There's nothing more we need to add. Human oversight using a dashboard, we already spoke about it. Trust should rise and fall with evidences. Always ensure that your decisions are evidence-based and not assumption-based. That's one of the classic mistakes most of the team does make. Reset is a control, not a convention. The tripwiring or the kill switch is very important. If you have seen the advertisement from many large AI companies about the kill switch engineer, what is that kill switch engineer? Is exactly this. Kill switches are most important control in terms of cybersecurity, and never ever let it lapse. Safe rule need explicit operator modes. Ensure you have a clear modes, and between those modes the proper containment boundaries are defined so you can do safe promotions. Now, this is more or less in this lesson. Instead of doing everything in real terms, we are going to simulate a lot, because bear in mind the sandboxing, if we add the real sandboxing, the system will become very complex. So we will make sandboxing as a simulation, but that will help us to understand what sandboxing should mean. Also, the other aspect that we will check the autonomy and the promotions. We will basically simulate those things. I'm more interested to explain as a process, and I'm more interested to explain and share the pattern and practices, because all of those elements are the courses on their own. For example, sandboxing. Sandboxing is a course on its own, around 5 or 6 lessons. How we can use Docker, or how we can build the sandboxing boundaries, least privilege principles, the cloud, and other access points that we have to control. That's a quite lengthier conversation to have. Autonomy is also quite lengthier conversation to have. So what I'm going to do in this particular course is I'm going to make them simulated. Simulation will help you to understand the concept, and simulation will help you to understand what in the real world cases should you expect about it. And there will be some nice example exercises at the end of it. So it will help you to also pour some more ideas and trigger the better solutions than what we have implemented, or advanced solution than what we have implemented. There are a couple of pins I have read in here. I would strongly recommend you to visit those. Those pins will help you to understand what the sandbox look like. In the terms of sandbox, they're just doing nothing but we're firing the exit button, and we are just checking the sandboxing as a wrapper. Then we have autonomy. The autonomy is nothing but just a simple state function that then add the trust, and it can let it go on and on as an infinite loop. However, the infinite loop can have also contain such as like how much tokens it can consume, or what's amount of in real terms what amount of money it can spend. For example, $5 or $6 if you got a cost calculations as well. So there are a lot of things you can apply there as those elements as well. And here you can see that how to run those and how to observe and validate them as well. And there are a lot of exercises as well. So what I'm gonna do is basically I'm gonna just clear this up, and we're gonna run the sandbox. We already run the re-ranking before, so we're just gonna run the sandbox. And by the way, this is just simply doing the simulation based on a previous run, so it's not actually going anywhere. But you can see here it executed the same command, same process using the simulator itself. Now, if we go back and fire Autonomy up to 5 round, then you can see how it simulated. So what it did is it actually took the 5 previous run and actually hold on based on that what level it should do. So currently we are at the supervised. Intel not think that we should go on autonomous level. The reason it should not go on autonomous level because the rating is coming very low and it's very inconsistent. So that's the idea. When you make a self-improving agent, they can also make this recommendation that what rate they are at the moment, what maturity levels they are, and can they actually go with the autonomy as well. Then the from history, if you see here, the level is supervised, but in history, we got a couple of other good runs, very good runs, where the rolling score is around 93, and that will allow them to actually go on a further levels. But here is my point is, even though they are simulated, it explains you how to implement, how to design those principles in your project, and how to build more comfortable systems, but well-constrained system. Bear in mind, the autonomy or autonomous systems are not the real solution. The real solution is to define the correct constraint boundaries and containment for those systems. Without them, they'll just become the random dot. They will not deliver the objectives and they will not fulfill the core area that we want to achieve out of it. So always make sure it is well constrained. Now, I think that's more than enough in my opinion to discuss. Otherwise, these are very deep concepts and we can keep going and keep going. Every concept that I discuss has 5 or 6 different alternate backends to implement. I have tried my best to design these exercises for understanding this concept in as clear clarity as possible. However, they do not give you the real practical experience, such as like using a virtual machine from a cloud or using a individual machine to run the agent itself with a more secure machine to run agent or Docker containers to run agent. The reason is because I don't want to diverge from understanding and designing principles to actually operational and implementation perspective. However, as I said, there will be a course coming next month, and that's all designed around security and sandboxing and these constraint mechanisms. So I'm sure that that will fulfill far more purpose than if I'm adding here. So let's wait for that. So make sure you subscribe and add the notification. I'm sure that next month you will find the remaining gaps which are not there in the production life cycle, but it will be more general, so it can apply on any agentic architecture. So obviously this is sufficiently good enough because this is self-improving agent anyways. Let's go back on our presentation then. Now you have full picture. Bounded mutation, autogen orchestration, observability, challenge pressure, re-ranking, and production safety. That's a complete mutation cycle. But here is a truth. It only matters if you apply it. Start small, pick one surface in your system, and build trustworthy loop around it. That's how the real system began. And if it helps you think differently, subscribe, stick around, and let's keep building. I'll see you in some other course. Take care. Have a good day then.